Okay, let's look at the addition and subtraction of vectors and also what a zero vector is. Okay, so here we have two vectors. We've got vector u. Let's go for some green flavour here. Okay, so we've got vector u and we've got vector v. Now, I'm not sure if I mentioned this before, but it's possible to label a vector using a bolded lowercase letter. So in this case, u, and here we've got v. Okay, that can also represent a vector. And you should also know, we've got things like from position A to B. Whoops, getting excited there. We could say from position A to B, there's a vector there. Okay, these are labels. These are generally labels that we use for vectors. So in this case here, we're using the lowercase bolded letters there. Okay, so we have these two vectors. Obviously, this is vector u. This is our x component. You can see here it's 5 in the length. And our y component, there is no y component in this particular vector. And this one here, 3 and 4. Now, if we're going to add them together, what does that mean? All right. So what that means is, basically, is that we're adding from u to v. It means that we're moving along vector u. Okay, so we're moving along vector u from the start of u. The direction is very important here. Okay, and then we're moving along vector v. Okay. So what we're actually doing is we're going head to tail. So when we're adding vectors, we're going head to tail. So the head of u attached to the tail of v, we start at the bottom of u, we go across, and we go up through v. That's what we're doing. Now, an important thing when we're looking at, well, one thing to know when we're doing vector addition is that it is commutative, okay, commutative, which means that order doesn't matter. So u plus v is the same as saying v plus u. And you can see here, this is u plus v, and we have this resultant vector, all right? And then we have v plus u, and it has this exact same resultant vector, all right? Now, we can do that. That's visually. You can see how that looks visually. But nice and simply, when we want to add vectors together, all we need to do is just add the components, okay? So here, we're just going to add the two x components. So 5 plus 3 will give us the resultant 8, and 0 plus 4 will give us 4. So nice and easy when we're adding vectors together, all right? Okay, but when we're subtracting vectors, these are not commutative, okay? U minus v is not the same thing, or here we go, is not the same thing as v minus u. Okay, so u minus v does not equal v minus u. What we're basically doing when we're subtracting vectors is we're still adding, but what we're doing is we're adding the negative of the second vector. So when we say u minus v, we're actually saying u plus negative v. Okay? And we can see that here in this diagram. So if I was going to add these two vectors together and I was going to use vector addition here, or let's say subtraction, we're going to subtract this vector from this one here, I'm going to add the negative of this one. So this is going to be 5, 0, plus the negative of this vector, negative 3, negative 4, okay, which will give us our resultant vector of 2 minus 4. Okay, so very important to note. Okay, vectors are subtracted by adding a negative vector. All right, now a zero vector is basically a vector is the resultant vector when we add vectors where they end at the same point that they began. Okay, so if we have a look at this triangle here, we've got three vectors. We've got vector RP, all right, if we go along RP and then we add PQ and then we add QR, we start and we finish at the same spot. So the resultant vector is going to be 0. So basically your displacement is 0. Okay? All right, so let's add some vectors together. I'll do a quick example here. And the first thing we're going to do is we're going to do a nice and simple one. We're just going to add these three component vectors here together, A and B. All right. So what we're going to do that is we're just going to add the coefficients of our units. All right. So we've got I. So we'll just go, okay, that's going to be equal to, let's add the coefficient of A here, of the I part there, the I component. So 2 plus the I4. Okay, and that's our I component plus the coefficients here, -3 plus -2. Okay, that's J. And then we're going to add our coefficients here, so 3 plus -1 for our K there. So nice and simply, 2 plus 4, we've got 6 in the I. Okay, -3 plus -2, so -3 plus -2 is going to be -5 in the J, plus 3 plus -1, so it's going to be plus 2K. Got a little bit ahead of myself there. All right, okay, so now we're going to do some subtraction. So that was the addition. Now remember, subtraction is basically just adding. We're going to add the negative version of A. Okay, so we're going to add the negative version of A. So let's do that again. Let's use a different flavour. Let's go back to blue flavour here. Okay, so with our coefficients, we've got B, so we're going to start with B. Remember, when we're subtracting, order is important. So let's start with B here, and we'll have 4. Okay, we're going to add the negative of our component. So the negative of 2 will be -2. All right, I there. Plus, we're adding again. All right, and we've got B, which is -2, and we're adding the negative. So the negative of 3 is going to be +3. Negative of -3 is +3. Okay, J plus -1 plus the negative. So plus -3 of K. Okay. So 4 plus -2 will give us our 2I. -2 plus 3 will give us 1. So that's just going to be plus J. Okay. And -1 plus -3 will give us our -4K. Okay. All right. One more example to go through. Now here we have 2B minus 3A. So it's a subtraction. All right. So we're going to add the negative of A, but we've got scalar multiples of those vectors. Okay. We've got a scalar multiple here of B, 2 times B, and we've got 3 times A. Okay. So if I want to write them out, let's move this up here so we can see what they are. So I can rewrite that and go, okay, what's my 2B will be equal to 8I minus 4J minus 2K, and then 3A is going to be 2 3s is 6I minus 9J plus 9k. Okay? All right, so now we're going to subtract then. Oops. So we're going to add the negative of this one here. We're going to add the negative of this one here. Okay, so we're going to have 8 plus the negative 6. Whoops, what have I done? Gotten excited. Let's try again. 8 plus negative 6. Okay, for our I component. Plus negative 4 plus negative, so the negative of negative 9 is going to be positive 9. Okay, for J, plus minus 2 plus the negative, so plus negative 9 here for our K. Okay, so 8 plus negative 6 is going to give us 2. So 2 in the I. Negative 4 plus 9 is going to give us 5. Positive 5 in the J. And then negative 2 plus negative 9 will give us negative 11 in the K. And we're done.